Trying to say chapter 3. Then I'm looking at you.
Hello.
Hi. Um,
Today, just give me a few minutes.
sorry?
Just give me a few more minutes.
Okay. Let me know. Alright.
Okay, I just want to share my screen. I just want to share my screen and then we can begin. So sorry, I received a lot of content in the past 10 minutes from your mom. So I was going through that content, just trying to see what I can focus on.
It's fine. Sorry, Christabella. I'm still trying to even escape chapter 3. It's Lola's fault, actually.
No, not a
Yes.
problem.
It's very disorganized. Not very organized.
Not a,
What she's
not a problem, not a problem. I just needed to go through the information first so that I can see and pinpoint areas that I feel need us to, you know, ponder on. Okay, can you see my screen?
Yeah.
Okay, okay. I opened the question paper that your mom sent me. I felt like we needed to go through it. There are some questions that I saw. I couldn't see whether it's marked or it's not marked. Like 1.1, 1.2 was correct. So I'm not sure why he canceled that, but it's okay. It's okay. We don't need to talk about that. Now that we've established that you can see my screen, then we can begin. How are you?
I'm finding you.
I'm good. I'm good. How was the exam today? I believe you were writing. I have your timetable with me.
Oh yeah, I was doing arts. Yeah, it was just art for 4 hours.
4 hours.
Yeah, but it was working on prac, so it wasn't like writing a test.
Okay, okay. Okay, interesting. I hope you nailed it.
Mm, yeah, I can still work on it at home. So yeah.
Oh, okay. That's actually, I think that's the beauty of doing subjects that are like IT, like art, like I think there's other schools that have technical graphics where they draw architectural um designs like houses and stuff.
Oh,
It's pretty cool. It's really, really cool. But yeah, I think let's get into a lesson. I saw that the test that you wrote, the one that I'm using for this class, is covering computer system components,
Mhm.
system performance optimization, buses as well, um, storage and interfaces, where it talks about caches and SATAs and basic computer functions, I think. And that's pretty much the essence of information technology. So we will go through that, and then we will, before we go through it though, I want you to tell me what you want me to focus on after we finish revising the question paper, because I feel like if we spend time um, going through information that you already know, we're going to be wasting the time.
Um, I just wanted
Yeah.
to go over the document that was sent on the group. It's the one that says, sorry, I'm just checking now. Local area network. I just wanted to
Okay.
see, we're supposed to just study it until network topology.
Okay. Network topology. Let me just check that out. I did open it, but I want to make sure that I see everything. Okay. Bus topology, you mean?
Well, from the teacher, he said that it's until network.
Okay. Okay. I see. I see what he's talking about. Mesh network topology, hybrid network, LANs and WLANs. Okay. 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 No, that's fine. That's until page 43, right?
Yeah. Sorry, I'm just checking again. Um, yeah, we stop at um, hybrid network, that part at the 32, 33.
Okay. Okay. Okay, dokes. Let me just send that to my email so that I can open it on my laptop.
Okay.
Um, okay. In the meantime, let's revise the question paper so that we don't waste our time. Okay, let's start with the first question. The first question is 10 marks, and it seems it's just defining terms or identifying the meaning of terms. So I have a PDF that has the answers to these questions. However, I didn't want you to see the PDF yet because I want you to use it for other things, like when I'm not there. When I'm
Uh,
there right now, we're going to be talking about it. We're not going to be checking out the information while we're revising it.
uh,
So the first question is asking uh, about the delay before a component response occurs following an intrusion. And I see you got that correctly. It is latency. Why is it
oh,
latency? Do you have a reason why you picked latency?
sorry, I was just gonna say that the answers next to the like first answers, those are like my corrections.
Oh, those are corrections. They're not.
Yeah.
Oh, that's why. Because I was wondering why did you make it wrong when you wrote latency? It's okay. Thank you for clarifying that because I was very confused. Like, am I getting the answers wrong?
No.
It's okay. It's okay. So the answer to the first question is latency. So you guys already went through this paper.
Yeah.
Oh, okay. So then it shouldn't be hard for you to tell me why latency is the correct question, is the correct answer, right?
Yeah. I
Okay. Perfect. Then why is it latency?
because in latency it's like latency it's I would say is like defined as um deciding whether there's like a delay or like a speed up with components.
Mm-hmm.
So like if there's less
Um,
late so, sorry, I was just gonna say like if there's less latency, then that means that it's like higher, but if there's more latency, then it's lower.
okay, that's correct. That is correct. Typically, it's the time delay between a cause and effect. So if let's say you're writing it down, you want to make sure that you mention the words time, you mention the words cause and effect, and you mention the words respond and instruction. So we're talking about the delay between a cause and effect, which in any context is the delay before a component responds to an instruction. So you're correct. Just make sure that your wording is, picking out the words that have to do with latency. I am going to give you, actually, you know what? Let me just show you the PDF now. You're writing your test tomorrow, so we don't have much time for the paper, actually. Let me upload it so that you see my answers. There it is. I have provided an answer and the reasoning behind the answer. And then the next question under that is asking a technique employed to increase the operational speed of a component. Why is it overclocking?
Because overclocking is like I know that I know that overclocking has to do with um like it's um putting in more than what like a certain component or device can handle. So
Yes.
yeah,
So
it's
that's
like
beyond its factory settings. When you're overclocking, people that work in IT support do that a lot. They overclock devices usually to fix them, but sometimes it's just to test if they're fixing the problem. Usually it's just trial and error. So they just overclock the devices. But it's increasing the operational speed of a component beyond its factory specifications. So you're correct. You're right on track. And then the next one is duplicating the registers on a chip. This allows the next instruction to be reloaded into the second set of registers while the first set of instructions are being processed. Why is the answer to that hyperthreading? What
mm,
is hyperthreading? They're giving us the description, they're giving us what it is, but why are we saying the answer is hyperthreading?
um mm,
Because hyperthreading originally is duplicating registers to process instructions concurrently. So basically, they gave us the answer.
Mhm.
Yeah, that is what hyperthreading is. Um, Usually, I don't know why he marked that wrong. Is that a not or is that a mark? This is correct,
Oh,
right?
sorry, I said no, yeah, 1.3, I said multiprocessing, and then the correction is hyperthreading.
Oh, on 1.3 when on 1.4. Okay, so you interchanged them. Okay, I see
Mhm.
that now. I see that now. Yeah, it is hyperthreading because hyperthreading is duplicating registers on chips. Um, that's the definition. And then 1.4, a hardware mechanism for improving the time it takes to read and write a hard disk, which is disk cache. And the reasoning behind that is that a disk cache is a hardware mechanism designed to speed up read and write operations on a hard disk. So the moment you hear something, the moment you hear a question asking you about time and read and write operations, then you know that that is the disk cache. That is what handles everything that has to do with operations that have to do with reading and writing and the time altogether. Any questions on that?
Mm-mm.
Okay. Um, and then 1.5. 1.5, the electrical path along which data is transmitted inside any digital electronic device. That's a bus.
Mhm.
That's a bus. There's so many, like buses are so multifaceted, but we're going to look at that after we finish revising this question paper. And then 1.6 is asking a device that regulates the timing and speed of all computer functions is called a system clock. You got that correct. Um, a system clock is responsible for regulating the timing and speed of computer functions. That's the definition of what a system clock is. And then 1.7, the type of RAM found in level 3 cache. Do you want to tell me why it's RAM?
Mm, why it's um
Why it's static? Yeah.
oh um the type of oh yeah, static means that it's um like permanent, like it stays.
Mm-hmm.
So level 3 cache, the I remember I had to remember this. Like with the level 3 cache is like stronger, so it's stronger than level 1 and 2, so it
Mm-hmm.
has more like um
More
permanent,
speed.
yeah, more speed and like permanent.
Yes, that's correct. That's correct. So with the RAM, it all depends on speed. Everything is about speed, speed and RAM together. So when we talk about levels 1 and 2 and 3 cache, the higher we go, the more speed we need. Because cache memory, the higher levels you go, the higher cache memory you need, the more speed you need to handle the memory. Got that?
Yeah.
Perfect. And then question 1.8, the portion of a CPU responsible for directing all activity. Yeah, I think you got that correctly. Yeah, it's a control unit. I think everybody knows that. Um, high speed memory is used to store that is used to store recently used data instructions. That is a cache drive. Why is it cache?
Um, because the hmm,
It's cache because cache memory is defined as high speed memory that stores frequently accessed data and instructions for quicker retrieval. I'm mostly asking you why, because I'm imagining a situation where they don't give you the meaning and they give you the word instead.
yeah.
So we need to work on that, and it's 10 marks. And usually the first question is the one that you need to nail more, because the higher the question number, the harder the questions get. I remember I always used to study question one more because I knew that the other questions were harder always.
Mhm.
So yeah, cache memory is defined as high-speed memory that stores frequently accessed data and instructions for quicker retrieval. Um, and then 1.10 is a signal to the processor via hardware or software indicating an event that needs attention. I think you got that correct. Am I right? I think you got that one correct. No, you didn't. Oh, okay. It's interrupt. It's interrupt because um, an interrupt is a signal that prompts the processor to attend to an event. I think it's in the word. A signal to the processor via the hardware for the processor to be able to signal, it needs an interruption. Something needs to cut it so that it focuses on the event that needs attention. So you need to interrupt it. That's the easy way to explain it. An interruption is a signal that promotes this processor to attend to an event. Any questions on those definitions that we just went through?
Sorry, I was just gonna ask if you could repeat interruption again.
Interruption, okay.
Mhm.
It says here a
Oh,
signal to the processor via hardware or software indicating an event that needs attention. And the meaning of an interrupt is a signal that prompts to the processor to attend to an event. But it's called an interrupt because it interrupts the movement of information that is happening at that moment, whether it's hardware or it's software, because an interruption needs to happen in order for an event to to be signaled that it needs attention. I don't know if that makes sense.
no, no, it
I can
does.
explain it again.
No, it does. Like,
Okay,
yeah, I
perfect.
get that it's like the word interrupt, like it's um it's like assessing a problem in
Mhm.
the network and then um like addressing it by giving
Yeah,
a signal to the processor.
exactly, exactly. And sometimes it's hardware related, sometimes it's software related, but the essence of it really is just the system needs an interruption in order for it to cut whatever it's doing to focus on something else.
Mhm.
Which is why um, cache memory. interrupt signals, what else? RAM. All of them are related because if you look at it the way that we look at it as developers, or just enjoy the hardware of the computer, the moment you click something, let's say you have an open document running in the background, and then you copy and paste something, then you get out of the document, you go do something else. While it's loading, while you're doing it, you go somewhere else. You are constantly interrupting the system. So the lower the RAM, the more terrible the computer is because it cannot handle all of those interruptions. It keeps on being cut and cut and cut and cut, so it can't handle it. But with more cache memory and more speed, it can handle all of those interruptions and still be able to perform um, all of the tasks that you're asking it to perform. I don't know if that makes sense, but that's how I understand it.
No, that's
Yeah. So going to question 2, the theory questions. Um, how did you feel about those ones?
sorry, about which ones?
Section B, theory questions.
Um, I was like half kind of,
Mm-hmm.
because I feel like in some of them I was second guessing myself.
Yeah.
So
It's actually
yeah.
what I was telling your mom last week, that half of the time I feel like you know exactly what the answer is. You just second guess yourself a lot,
Mm.
and you should stop because half the time you know exactly what you're talking about.
Yeah, I think it's just I'm confused on how to like word it.
Mm-hmm.
So, because like know that this is what it's supposed to be, but like I get a bit confused on how to word it, and then like I decide
Mm.
to go for something else that like I know I'd be able to word, and then it's the wrong thing.
Mm. No, no, it's fine. I think that's why I've been doing those PDFs. I'm going to make sure that you have it. Actually, I'll send it just after the lesson so that what happened last week doesn't happen.
Mhm.
I'll send it as soon
Yeah,
as we finish the lesson so that you can use it to study.
thank
Familiarize
you.
yourself with the words, the work that is the wording that they use in the textbooks, but then the textbook wording is very, I don't know, it's very serious. It's very
Mhm.
her. Very very hard to
Like my
understand.
yeah.
Yes, I have these PDFs for you with simpler English, and you can just familiarize yourself with those words, and then that way it's easier for you to remember when you're writing your test.
Thanks.
Yeah. So moving on to the section B, they said here for each of the questions below, you need to circle the most correct answer from options A to B. And then the address bus is unidirectional. That's the answer. It's unidirectional because they transmit memory addresses from the CPU to other components only in one direction, which makes it unidirectional. Uni means one, right?
Okay.
Yeah. Uni is one. Uno. Uno, dos, one, two.
Mm.
Uno, unidirectional. Because it transmits memory directly from the CPU to other components, only in one direction, I mean.
Okay.
And then static RAM, you said, let's see what you said. You said static RAM is only used to store data from static variables. No, static RAM does not need to be refreshed. Why does it not need to be refreshed? Remember in the last question, we talked about how cache memory level 3 is static. and we said it's static RAM because it's faster, right?
Yeah.
So because it's faster, that means it does not need to be refreshed,
Mhm.
right?
Yeah.
So that's the reasoning behind it. Um, my reasoning on my document, what did I say? Let's see if I'm saying one thing. Let's see. Okay, yes. Unlike DRAM, static RAM retains data as long as power is supplied without needing constant refreshing. That was the reasoning behind that. Um, and then 2.3 is asking hyperthreading is a feature that simulates multiple CPU cores. Why did you choose that answer?
Um, because hyperthreading, I remember it, um, like hyper, when I remembered it, I was thinking like many,
Mm-hmm.
so, but I was also thinking fast because like
Mm-hmm.
hyper, like, yeah, like
Yeah.
excited. Um, so I went with, the option simulates multiple CPU cores because I did also remember how hyperthreading, like
You're correct.
it works with like
You're correct.
multiple.
Yeah, that's the correct definition. It allows for one CPU to function as multiple logical cores by handling multiple instruction threads. Um, which is also related to RAM. You can only be able to handle multiple instruction threads concurrently if the RAM is high. By you, I actually mean the CPU can only be able to handle so much if, you know. So hyperthreading usually we talk about it when the RAM is higher and it's like a better computer specifications. Um, so you're correct and your reasoning is correct as well. It's right on track. It's always wise to do what you did right now. You see how you made a connection with regards to hyper and speed and what hyper means and how hyper and threading together can mean multiple.
Mhm.
That's exactly the logic that you should use when you're writing your tests. It works really well. So just make connections with different words and you'll be fine. And then 2.4, moving on to 2.4 is saying SATA is an interface suitable for connecting um, a hard disk drive. We said a hard disk drive because SATA stands for serial. Do you want to tell me what it stands for?
Is it? I know it's serial access.
Serial
Oh,
advanced
serial advanced. Ta-
technology attachment.
Okay.
Yes. Serial Advanced Technology Attachment is a standard interface primarily used for connecting storage devices like hard disk drives and solid state drives. So if they ask you what it is, or what it connects, then you know it connects hard disk drives. Sometimes they will not put hard disk drive as an option. Maybe they'll put solid state drives, which is SSD, and you pick SSD. Like here, they didn't put SSD. solid state drives. But in any case, they might remove hard disk drive and put solid state drive instead of hard disk drive. Then you know that you can pick that one
Mhm.
instead. And then 2.5 is asking about the system clock. You got that one correct. Um, you got it correct, but you selected the other one. Oh, that's the other correct one.
Yeah.
Okay, I see that now. I see that now. And then what does DDR represent in RAM? You got that correct as well. Dynamic RAM. Dynamic and static are both very fast. And I see here in the other question where you were naming, you got it correct as well. You wrote dynamic or static. They both work for level 3 cache because they have high speed and they can handle a lot of memory. So I'm happy about that. You made the connection and I love that. And then 2.9, what is the main feature of PROM? What is PROM?
Uh,
Let's start there.
as a process.
Programmable read-only memory.
Okay.
Yeah, it's programmable read-only memory, and it can be programmed after manufacturing. And it contains contents that cannot be erased or modified thereafter because from the word read-only memory, there's nothing that can be done to it. It's just there. So if they ask what is the main feature, it's that it cannot be changed ever. It's read-only. So if you know what PROM means, then you know what its main feature is, right?
Mhm.
So what it stands for is programmable, read-only.
Read-only memory.
Yes, right. So its main feature is that it can't be changed. Why can't it be changed?
Um, it can't be changed because it's it's a fixed
Yes, it's read-only information. The
yeah.
contents of it cannot be edited. They cannot be reprogrammed. You can't do anything to it. It's just a read-only file. Just like let's see. Just like the HTML files that come with our phones. Um, is an exercise that I want us to do maybe tomorrow or in the next week or whenever we get a chance to have another task. We can do an exercise where we explore the developer options on our phones. It's actually really smart. It's amazing how much we can do with our phones and we don't know.
Mm.
I recently went through it and we were working on an app from the laptop, but we were able to use it on the phone with a USB cable, and it was amazing, to be honest. We were using those PROMs.
Oh,
Yeah.
okay.
So, yeah. But anyways, moving on to question 3, which is applications, and it's the most amount of marks. It seems it's 30 marks, right?
Yeah.
Gonna be 30 marks. Do you want to read the scenario for me?
Um, it says AJ Garden Services offer homeowners in urban areas a small range of garden services, lawn maintenance, weeding, edging, and pool maintenance. The business is operated from the home of the owner, AJ, and employs a small number of staff who are paid to undertake the work in customers' gardens. In addition to the maintenance options offered, the company also offers a design service where they can produce a 3D garden design. Um,
Okay.
This so it says the office has a single desktop computer that is used for all functions of the business. This desktop is several years old. It needs to be replaced. Any desktop will have a CPU. Name of the Name one manufacturer of CPUs typically found in desktop computers.
Okay, and when you did corrections, you got AMD, Apple, Samsung, and all those names. Um, why did we say AMD and NVIDIA? We said that because those are the listed manufacturers in the context of the
Mhm.
CPU discussions. It's in the scenario, um, right?
Yeah.
Yeah. And then yeah, it's also very important to pay attention to wording. I don't know why they set the papers like that, but I've always said I don't know why they like to hide information. Like just ask the questions straightforward, but it's fine. Yeah. They should just give us the information properly and not try to play hide and seek. But it's
Yeah.
fine. 3.1.2 CPUs have three main components. Name three components and briefly describe the functions of each component. And I see here you did pretty well with that. Control unit. Um, what's that second one?
I said ALU, but it's not. Yeah. Well, actually,
Yeah, I
yeah, it
see.
is. No, it is. It's just, yeah, my definition was, or my function was not.
Mm-hmm.
Yeah.
Yeah. Okay. So for me, what I did was also ALU, which is arithmetic logic unit. The third component, I said registers. For the first one, which is control unit, I just said it directs all activity to the CPU. That's the first component, right? And then the second component, let me just open the answers for you so that you see. Okay. And then the arithmetic logic unit, it performs arithmetic options or operations, which is mathematical operations, addition, subtraction, logical operations, comparisons, and stuff like that.
Mhm.
And then registers, their function is high-speed storage locations within the CPU that temporarily hold data and instructions during processing. That's a lot of words. That is a lot of words, and I don't want you to memorize all of those words. With ALU, I want you to memorize that it performs mathematical operations. Arithmetic is mathematics, right?
Mhm.
So don't try to memorize the arithmetic operations thing. It's just gonna, it's just gonna confuse you. So just say that the function is that it performs all mathematical operations in the system. And if they ask you to name them, you know what mathematical operations are. It's addition, it's subtraction, it's multiplication, it's logical operations, it's comparisons, bigger or smaller, right?
Mhm.
Things like that. And then with registers, you don't need to memorize all of this information. All you need to memorize is that it's a high-speed storage location within the CPU. I am pretty sure that your teacher is not going to remove marks for you if you leave out the part where it talks about how they temporarily hold data or how the instructions during processing and whatnot. The main function of registers is that they are high-speed storage locations within the CPU, and that's it.
Okay.
Yeah. So pay attention to that too. Don't try to memorize a whole load of data. It's just going to I know I don't remember how we used to do how many subjects. So it's three majors, it's two languages. and mathematics. I don't remember how we used to do it. And going to varsity and doing 3 courses per semester makes you realize that high school is actually slavery. But you know what? It's fine. So don't memorize too much information. Pay attention to the keywords and stick to those. Those are your guns. Yeah. So moving on to the next question, is asking the current desktop CPU has registers that uses 32 bits. Many modern processors have registers that use 64 bits. Explain to AJ how a CPU with 64 bits will improve the performance of the desktop computer. Okay. Do you want to explain to me? You guys did corrections, right? So maybe you can tell me what your teacher said.
Um, so the 64 bits usually improves the so like 64 bits will improve because it will increase the um speed by looking at the what's it? The cache memory.
Mm-hmm.
So it'll it'll like increase the speed using cache memory, and then also would it I know that the 64 bits um will improve the like screen quality because it improves like the what's it? Um
RAM.
yeah, the
Yeah. So a CPU with 64-bit registers improves performance by allowing the processor to handle and to process larger amounts of data. So when you think about 64-bit, 32-bit, think about data, think about speed, think about cache memory, think about RAM, which is exactly what you were thinking about. And I can see that you were struggling with which words to use to explain that, right?
Mhm.
So you want to say 64-bit registers improve performance by allowing the processor to handle and to process large amounts of data in a single operation compared to the 34-bit CPU. And then you want to talk about how. So you say this results in a faster execution of instructions and the ability to access and utilize more RAM, leading to a significant increase in overall system speed and efficiency, especially for the demanding applications that need more cache memory. That's a lot of information, but if you make sense of it, it's more of they're asking us to explain to AJ how 64 bits is going to improve. So how will it improve? It will improve by allowing him to process more data in one operation. It will also increase the overall speed of the system that he's using. He will also be able to run demanding applications, and the efficiency in general is going to be faster. His laptop is going to respond to clicks faster. His laptop is going to be able to open much more applications at the same time than it used to be able to do with 34-bit CPU and stuff like that. Try as much as you can to not think in dictionary mode. Think in conversational mode when you're trying to explain, right? Think
Mhm.
of it like you're explaining to your friend. It makes it much, much more easier because, anyways, your vocabulary is already good. From the way you speak, I can hear that you have enough vocabulary. So just use it, but in a more conversational tone. You
Uh,
get, yeah.
mm.
That way you will be able to make use of the information that you know. And then, so we've spoken about 3.1.3. Now we're on 3.2. Modern processors make use of caches. AJ needs to know how different caches on a desktop will improve the performance of the machine. And then the first question is, name the cache that is the fastest. And the answer to that is the fastest. Wait. Where are we? 3.2.1. Okay.
Yeah.
Name the cache that is the fastest. We said level 1 cache. Then the reasoning is that level 1 cache is the fastest and the smallest level of cache, located closest to the CPU core for immediate data access. So just know. And then name the lowest cache. It's level 3. Cache levels are hierarchical, right? It's like a triangle. Like a triangle where level 1 is the fastest, level 3 on the down low because it's the largest. So this is the smallest on a triangle format, smallest, second smallest, and then the larger one, right? And then, so the lowest cache is level 3. Level 3, wait, just give me one moment. I want to show you something. Okay. Okay, think of it like that. Okay. So level 1 cache memory is the smallest. Imagine something that looks a little bit like this, like the triangle that I just drew there.
Okay.
That's why it's the smallest. And then here they asking about where level 3 is located. It is located in the ALU. What did we say is the ALU?
Arithmetic logical units.
Exactly. It's located in the ALU because while traditionally level 3 was on the motherboard, the modern CPUs often integrate level 3 cache directly onto the processor die, accessible by all cores. Closer to the ALU because it needs to be working together. I don't know what the other reason was though. Let me actually just check so that I say the right thing.
Okay.
Okay. Here it says that primarily to minimize the latency and the delay in accessing data. Okay, so it's to decrease the ping, to make it faster. That makes sense. That makes a lot of sense. Remember, we said the lower the latency, the faster it is.
Yeah,
The higher the latency,
the slower.
yeah, exactly. So that makes sense. And then 3.3.1, what is meant by overclocking? We already talked about that. I think you can tell me what it is.
So overclocking is when um um is it a network or I know that it's when it's like over like worked or like processed when it's then its initial um like
Exactly. You're
yeah.
getting it right. You're getting it right. Um, Overclocking is the process of overriding the factory setting of the said computer or the said hardware. Uh, I think when we were talking about it, I said that most IT support guys, they usually just overclock the devices to just make it faster,
Mm,
um, or to make it operate at a higher frequency than the original design. It increases performance. It's a good thing. But if you overclock your device too many times, it ends up not responding to overclocking. At some point, it reaches a plateau. So, yeah. And then explain the difference between uh, per component overclocking and whole system overclocking. It's in the word. So here it says per component overclocking. You can go straight to a component, right? Say you want to increase the speed of your RAM or the CPU or whatever individual component. Sometimes people overclock their uh, SSDs, the RAMs. What else can be overclocked for speed? Not sure about the ALU because I've never read about it. But basically, you're focusing on a particular component of the system, um, and you're overclocking that part, right? And then that brings us to the whole system overclocking, which involves increasing the speed of the whole CPU, which is including everything, the CPU, the RAM, the system bus, everything at once, right?
mhm.
Yeah. So if it says per component, then just know that we're focusing on one individual component. Um, and then the whole system, then we're focusing on the whole system, which is everything in the system is overclocked. And then um, briefly describe the following terms. Okay, I think you are going to be leading this one. What is hyperthreading?
It's when um hyperthreading is when the speed is like when it like processes multiple mm, was it CPUs? Oh yeah, like it processes multiple networks at like a fast speed. Um
Okay, you have the right words, just the wrong placement.
okay.
Hyperthreading is a technology that allows a single CPU to execute multiple instruction threads concurrently by creating two logical processes per core, right?
Yeah.
Basically, it involves duplicating the registers on the chip, enabling more tasks to be handled parallel in a parallel way. But basically, we spoke about this before. Remember?
Yeah.
Yeah, we spoke about it. And when we spoke about it, we mentioned that it allows a single CPU to function as multiple logical cores by handling multiple instruction threads, right?
Mhm.
So it's one CPU core functioning as multiple logical cores by handling multiple instruction threads concurrently. effectively as well. So it's not hyperthreading if it's failing.
Yeah.
It's hyperthreading if it's able to function as multiple logical cores and handling multiple instruction threads and doing it effectively as well.
Hmm.
Did you get that?
Yeah.
Okay, perfect. And what is multiprocessing?
So multiprocessing is like it's when um it takes the operating system and it like processes many systems at once. So like
Okay, it refers to two or more CPUs. So it's two CPUs or more within one computer system.
okay.
So we're talking about two CPUs in one computer to execute multiple processes at the same time. So basically, why do people end up multiprocessing? To improve the performance and the output. When you use two CPUs, it means you have doubled the power. Or I don't know if that makes sense. Does it make sense?
Yeah, yeah, it does.
Yeah. So when you say multiprocessing, you are not talking about the operating system or whatnot. You're talking about the CPU, central processing units, two of them or three of them. So they might ask, why do people multiprocess? To execute more tasks simultaneously or to execute more tasks at the same time faster, right? And then,
Yeah.
so there's multiprocessing, there's parallel processing. Parallel processing now is uh it's a computational model. I don't know how to reduce that into something that we can both understand without breaking our heads, but it's where multiple processing units work together simultaneously to execute different parts of a program or multiple programs to complete tasks much faster than a single processor could. So we're talking about one computer with many processors, with many CPUs, and another on the side with many CPUs as well. So parallel means two, right?
Hmm.
Yeah, parallel means two. Parallel processing, two computers that have multiple processors, and then multiprocessing is one computer with many CPUs. I don't know if that makes sense. So basically, parallel processing is multiprocessing times two, but executing the same tasks at the same time.
Okay.
Yeah. Do you understand that though?
Yeah.
Okay. I think I want to
Um,
explain it again. What did you say?
no, sorry, I was just gonna ask a small like favor.
Mm-hmm.
Would it be okay if I like took a short like 5 minute break to just like get some water?
No, no, that's okay. That's okay. You can go actually. I actually want to go pee as well.
Oh, okay. Thank you so much.
Oh, sure, sure.
Okay.
I'm actually currently downloading the local area networks document so that I can use it after this.
Okay.
Um, yeah. For future reference, do you think maybe we should incorporate 5-minute breaks more often?
Yes, please.
Okay, perfect.
Sorry, it's
Feel
just
free to.
yeah, it's just like with 2 hours, I do tend to
Oh,
disassociate a bit. So
it's okay. Not a problem. Feel free to guide me as well because I want our learning environment to be as free as possible. There's no reason why people need to make learning boring.
mm,
I hate that. Yeah. So you can okay, we can wait for the 5 minutes to finish while I upload this document that I just downloaded.
okay.
Okay, okay. We were on, we were talking about multiprocessing and the difference in between those two. And I was saying that multiprocessing is a processing technique, right? In which multiple processes are used in a single computer and they each work on a different job, right? And
Mm,
then parallel processing now is a processing technique, another processing technique in which the multiple processes or multiple processing cores in a single computer network work together to complete one job, to complete one job faster. Does that make sense?
yeah.
Yeah. So parallel, they're completing one task together. Then multiprocessing, uh, they're different. They're processing different tasks by separating them into multiple parts and completing them simultaneously at the same time. Parallel processing, one task. Multi, different tasks performed at the same time, right?
Mm,
Perfect. Perfect. And then moving on to the next. question. I think we're almost done. Address bus. Um, address buses are okay. Here's the answer. You can read it out for me.
Um, Undirectional electrical path with a computer system that carries memory addresses from the CPU to main memory or other input-out devices.
Okay. It
It's
says
sorry.
unidirectional.
Mm,
Remember, we said it's unidirectional.
Yeah,
Yeah. Uni, we said uni means one. So
yeah. Oh,
unidirectional
yeah,
means that
one.
it moves in one direction,
Anyway.
right?
Mm,
Exactly. Um, so the control bus is an electrical pathway that transmits control signals and commands from the CPU to other components of the computer systems, such as memory and I/O devices. It directs and coordinates operations, ensuring proper communication and data flow within the system. Do you have any questions with regards to the control bus? Pretty straightforward.
mm-mm.
Okay, perfect. Now I want us to revise the document that you said you want us to focus on.
Yeah.
I want us to do that. Just give me one moment while I share that.
Okay.
Okay, so I have, where is it? Where is it? Where- Give me one moment. I'm just saving the document now.
Okay.
So what I did was I took all of the information and I compiled a list of questions based on that information, right?
Okay.
Yeah. So that's what we're going to be doing. Because if we just revise the information willy-nilly, local area. Okay. Can you see that?
Yeah.
Does optimize mean? Why is it there? Perfect. So I have question and answers with regards to, I mean, based on the document that you gave me. I'm going to open the document as well. Um, and then the first question that I came up with is what is a computer network and what is the primary purpose? Do you want to read out the answer for me? I think I want you
Uh,
to lead here so that it's your
uh,
document.
mhm. So it says a computer network is developed by linking computer systems together. Its primary purpose is to enable these systems to communicate with each other, share computing power, and share storage facilities.
Mhm. What does it say next?
And then, uh, oh,
The
sorry, were
next
you asking us?
question.
What are the two main categories of networks based on geographical area? So
Uh,
that's
the two main categories of networks based on geographical area. You want to think about LAN and WAN.
okay. So, um, then you'd say networks can be categorized as local area network, which um sorry, the thing is our teacher said for us to not go over
The computer area networks.
yeah, no, he said that we haven't gone over the wide area network, so we shouldn't go over that. And then I think
Okay.
because local area network like entwines with the wide area network, then we wouldn't really see much of LAN either.
Okay. Okay. Um, Here I was just what do you call it? The questions are basically just based on the two categories of networks, which is WAN and LAN. And then I think that's it. I think those are the only questions based on that. Let me just check. So anything to do with LAN, I should leave it alone.
Yeah, I think so. Yeah.
Okay. So what do you want to focus on exactly? Maybe pinpoint that for me.
Um, there's like networks and then the mm, what else? Uh, hmm. Sorry, I'm just checking on the document.
Okay. Take your time. He said we should do networks.
Yeah, the like uses of networks over there, and then
Mm-hmm.
also just basically everything else. So like advantages, disadvantages of networks, the
Mm-hmm.
infrastructure, yeah, the hardware, the software,
Transfer of files.
transfer of files. Yeah,
Okay. Okay. Network infrastructure, hardware, software, and then LAN network topologies. Should we leave that
I think
out?
actually I think we can just go like briefly over LAN network topologies
Okay. Okay. I
because
think
like
my
we haven't.
questions are, yeah, I have a few questions on network topologies and mesh network topology as well, and hybrid network. A few on types of network. What else? I think that's it. Yeah. Communication media. Okay. Okay. Mesh network topology as well. Would you like me to go through that as well?
Yeah.
Okay. Cool, cool, cool. Then we leave that out. All right. Okay, okay. Let's see what I did here. Okay. Uses and benefits of network, is that okay?
Yeah.
Okay. So let's start here then. Name two primary uses of computer networks. The two primary uses of computer networks are communication and sharing resources, e.g., sometimes with printers, data, um, Office 365, social media, and emails. That's pretty straightforward. Um, and then we have the concept of centralization of data in the network. Do you want to talk about that, centralization of data? What do you think it is?
Um, did you say centralization of data? I think
Yes.
that's like the prioritization of data. Uh, so like the places where data is um like primarily found.
Mm-hmm.
So like in servers and then also in
You're actually correct, yeah.
oh
Centralization of data means that data can be data can be stored in one central server instead of multiple places. It's in the word centralization of data. It means that it's stored in one central server. This eliminates the need to copy data between machines, and any computer connected to the server can access the data. So basically, centralization of data is like how we have our information on on our Google Drive. That means that if it's on Google Drive, you don't need to be sending it to different phones or transferring your data manually, like sending it to the other phone or copying and pasting. You don't need to do that because it's in one place, it's on the cloud. The essence of the cloud is to centralize people's information, putting it in one place and being able to access the information when you're anyway on any other device. You can just log in to your Google Drive and you're able to access your data, right?
Mhm.
So that's an example of centralization of data. Um, no need to copy data from one machine to another. Any computer can have access to the data as long as it's connected to the server. So that's centralization of data. And then the next question that I came up with is list 3 ways files can be shared between computers that are connected to the same network. Three ways that you can transfer files.
You can upload it to a website.
Mm-hmm. One.
Um, then it's sending an email with the file.
Mm-hmm.
Um,
Attachments as attachments.
oh yeah, as attachments.
Mm-hmm.
Um, then you can also place the files on a network attached storage device.
Exactly. And you can also include what I spoke about with the Google Drive and stuff.
Oh yeah.
Yeah, and then you have it under control. Sharing websites, Google Drive, OneDrive, Dropbox, emails as attachments, network attached storage device. This is so nice because you guys are learning things that are practical, things that you guys do. I think I think as much as us, like my generation of students, we had phones and stuff, but we didn't really explore them as much as you guys are exploring your phones. Like you guys literally have Google, what do you call it? Google accounts already. You know what the cloud is, you know how to use it. So this is practical information for you.
Mhm.
Yeah. So moving forward to the next question that I came up with under transferring of files, state 3 advantages of networking computers. 3 advantages of networking computers. So the first advantage that is listed here in these notes is that computers can communicate with each other easily. They can share data and files, and hardware such as printers can be shared as well. Can you give me the rest of the other advantages?
Um, so you said the advantages of network computers is it communicates easily with each other, then
Mm-hmm.
shares data and files, and then also um uh
Computing power and storage facilities can be shared as well.
oh, okay.
Yes. There is control over which programs, data, and hardware a user has access to.
Mhm.
So when you think about networking and transferring of files and stuff, I go ahead and straight on think about GitHub. Do you know how to use GitHub?
Kinda.
Okay. If in any case, this is a very exclusive and once in a lifetime offer that I'm making here. If ever in the next 3 years you decide to study something to do with coding, programming, software development, and whatnot, you can text me and I can be your mentor because I generally like to impart knowledge. I can teach you how to use GitHub. So, in the conversation of networking, GitHub is basically the essence of networking because when you're programming or you're coding, you need GitHub to track the changes. So what GitHub does, it allows you to control who has access to the data, who can edit, who can make changes, who can push, who can pull, who can um, transfer the data to somebody else. Is it read-only documents when it's being viewed by anybody else and stuff like that. So yeah.
Okay.
And then, okay, so answering list 3 ways files can be shared between computers connected to the same network. 3 advantages, and then the disadvantages of networking computers. The disadvantages include the easier spread of viruses, the greater need for security due to the shared data. When you're sharing data, you need to make sure that it's encrypted and that everybody else that is outside of the network cannot see the data that is being shared in the network, right?
Yeah.
Um, the other disadvantage is that the impact on all workstations if the server fails. If the server stops working, all the information that is on that server cannot be accessed. You cannot access it on my computer, you can't access it on your computer. It's gone. Everything is gone. So that's the disadvantage of having all the data on one cloud or on one server. It's also higher installation costs. You see how we have to have multiple Google Drives because if you don't have multiple Google Drives, it's going to get full and it's going to start asking you to pay because
Mm.
it's generally expensive to have your information or your data on a cloud or on a server, right?
Yeah.
Yeah. Are you still with me or do you want to rest? I can see you're
Um,
you're a little bit tired, which is understandable.
no, sorry. It's just it's been a long day because I had to sit through a 4 hour. Yeah, I told you
Yeah. Yeah.
yeah, so it's like me sitting down and then like working on like this project thing.
Mm-hmm. Mm-hmm. No, I understand. I understand, and I'm picking up on your concentration. You're still with me, but I'm wondering if you're understanding everything. And I have no problem with us stopping here. And then I send you all the documents. You just tell me how you feel.
Um, I think I don't know, because I think I will be good with like the because all the stuff that we're going through is like we did go through it in class and I did find it pretty like easy to understand. I think it's just a
Mm-hmm.
matter of me also just like going through it again and just like making sure it's memorized.
Mm-mm. And how do you study? When you're studying, how do you memorize your information?
So like usually I'll repetitively repeat repetitively
Repetitively.
English didn't yeah repetitively like say it to myself.
Mm-hmm.
But yeah, that's
Okay.
like not like all the time I do that, but like I'd also try stuff
Okay.
so like I can picture like she
Mm. Okay. Do you have a printer at home?
Yes, but it doesn't have ink.
Okay. No, that's fine. If it doesn't have ink, then let's leave out the printer. I have sent the documents on WhatsApp. You can put them on your laptop, right? And then you write out the information in words that you understand. So you read it out and then you write it down.
Okay.
I'm assuming that you're probably going to go sleep and then you're
Um,
gonna wake up later, or you're gonna sleep late and then
um, usually I like to just study first and then sleep and then like, because when I sleep for a very long time. So
mm-hmm.
yeah, so like I think I'll just like study and then I usually go to bed at like it depends honestly, because
Yeah, yeah.
commonly, because like I write this exam in the morning tomorrow, so like because there's like so like to explain it is like usually there's two exams that people write in one day, but like obviously it depends on what subject you're doing and all of that. So
Mm-hmm. So it's 2 sessions of exams.
yeah, so like tomorrow I'm only gonna be writing IT and then I can come back home. So but yeah, that's me writing from 9 to 11 a.m.
Okay, okay.
Yes.
So you're gonna study first before going to bed.
Yeah, and then like usually I wake up, it depends, but like I can set an alarm to wake up at like 6:30 to just go over my stuff.
Mm-hmm. Just
Yeah,
before the exam to
just
just go over it.
refresh. Yeah.
Okay. No, it's fine. Um, I have sent the documents. The question and answers local area networks lesson 3 is the one that has the information that we're talking about right now.
Okay.
And so I would suggest that you go through that one first.
Okay.
Yeah, because the other one is just the class that it's the corrections. You already did the corrections with your teacher. You guys already went through that information. So rather go through the local area networks question and answers, the document that I made. And when you're going through it, try to write it down. Try to write down the answers as
Mm,
you are studying. Um, yeah,
okay.
yeah, that's my advice. Do you want me to keep going, or would you rather we stop here?
Mhm.
It's all about you. I'm here for you. Remember that.
Yeah, thank you. I think it's just when I end a lesson early, it or like or like when I end it before the assigned time, I
Mm-hmm.
don't know, this it feels like there's this guilt inside of me because
It's okay. Let's go up until 8 then.
but I don't know, because I don't want to like because I can feel like my attention span losing, but like because I don't want to like lose my attention when because then
Mm.
it'll just be like this is for nothing. So
Yes, 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 yes.
yeah.
That's what I'm trying to avoid. So let's just do the next 15 minutes and talk about the next questions maybe. But maybe let's have you lead that section of the class so that you stay in check.
Okay.
Yeah, let's do it like that. So the next questions are talking about network infrastructure and components, which is here. It's the next section. Network infrastructure and components. The question is, what are the two main categories of components that form network infrastructure?
Two main categories. So the two main categories are hardware and so yeah, the local area network cards, routers, switches,
Mm-hmm.
wireless routers, cabling, and then the software. So it's hardware and software. And that's with the software, it's network operating systems, firewalls, security applications. Okay.
Okay, so if a question asks, give me any three types of hardware, what will you say?
Um, so I'll say the LAN cards and then
Mm-hmm.
routers
Routers.
and
Mm-hmm.
switches, yeah.
Mm-hmm. Cabling,
Okay.
keyboards, mouses, um, CPU, and stuff. And then if
Mhm.
they say three types of software, then you talk about NPSs, firewalls, security applications, and everything that is to do with software, right?
Uh,
Yeah. Um, and they actually mentioned that list four common hardware components, and we've already spoken about this. Identify four types of nodes that can be connected to a network.
what types of nodes? Um, so common hardware components found in a network infrastructure. So that's common hardware components are the LAN cards, as mentioned before, the routers, switches, wireless routers, and cabling. Okay.
Yes. And then the four types of nodes that can be connected to a network.
Nodes refer to devices connected to the network to send and receive data, such as
Yes.
workstations, PCSs, so that's printers, servers, and access points. So,
Yes. So if we talk about nodes, we're talking about printers, we're talking about servers and access points. Why are these things nodes? They're nodes because they send and receive data.
okay,
Printers, printers receive data and they print out the papers with the information. Servers, they receive and send data on the server. And then access points, um, yeah, and access points. So those are the four types of nodes that can be connected to the network. If they ask what is a node, what do you say
you could like specifically or just like what is a node in general?
in general?
Um, so a node is like a component, I guess, of
Mm-hmm.
like a dev it's the components of a device. Um,
Connected to a network.
okay,
Yes, so it's a device connected to the network that can send and receive data. That's it.
okay,
Yeah. So the main components of nodes is that they can send and receive data. That's it.
okay.
Yeah. And then the next question that I actually like these questions because these sound like questions that they might want to play around with. Is it just me or we might have hit something here? We're on to something.
Yeah.
And then the next question is what is the function of a network interface controller? And over here, I said that a network interface controller is a hardware component that allows a device to connect to a network. I think it's very straightforward. network NIC. It's a hardware component that allows a device to connect to a network. All right.
Okay.
Yeah. And then the last question that we're going to be looking at tonight before we close. Do you want to lead that one? I've highlighted it in red.
Okay. What is the role of a network operating system? So,
Mm-hmm.
a network operating system is an operating system that enables the creation and operation of a network. So, also it
Okay.
like supports um the network.
Continue. Okay. Yes, exactly.
Okay.
Spot on. Um, I think now what I need to know is when is the next time you're going to be writing a test or an exam?
So tomorrow is actually my last exam for, well, not exactly, but like it's my last one for IT. So yeah.
Okay, that's good news.
Hmm.
That's actually good news. Um, and then you guys are gonna go on holiday?
Yeah, so like basically it's so tomorrow I'm writing IT and then Wednesday it's English and then art theory and then Thursday I have a free day and then Friday I'm doing a drama prac and then that's it. And then it's basically I'm basically free because we only go on holiday I think either next week or the following week, like early
Mm-hmm.
following week.
Okay. No, no, it's fine. Then that means I won't be seeing you for a very long time. Um, but that's fine. You just keep communicating with me and tell me when you need me. But for now, just make use of the documents that I sent you, and I think you're gonna be fine.
Hmm.
I think you'll be fine. Good luck.
Thank you. Thank you so
You
much for
do.
the help.
You're welcome. You're welcome. Have a good rest of the evening.
You too.
Sure.
Okay, bye.